going to start it. This is ITS128 on October 15th. And sorry for the late start. Let me share my screen. 1, 2. All right, there we are. And it's this class. And today is October around here. Oh, good. So we're into chapter 6, functions. Okay. So let's open up the textbook. And go to chapter 6. 6. Let's start here. Let's see. All right, user-defined functions. Okay, so we've been using functions. We've been using functions all the time. When we print, we use the print function. When we anything where we have the name of a program followed by a parentheses and then some parameter or argument and then end parentheses. Okay, anywhere you have that, you are calling a function. Sometimes functions actually return values, and that, so when you see a function inside of an expression, then that is a function that returns values. But sometimes you don't see functions in expressions, like for example, the print function. Whenever you see the print function, it's sitting there out all by itself, print something, but it's a function. And so those are system defined or system provided functions. You can write your own functions. And in fact, you name them what you want, you define the parameters, what you want, you do the computation inside the function. It's another little program. And then when you're all done, you return these values, these values that the final computations of what the function does, and you make those values available to the program that called the function. And so that's what's going on here. So this first section is the motivation for this, and it can reduce redundancy. So let's say you're computing converting a bunch of Fahrenheit degrees into Celsius degrees. Let's say you're doing that, and you got 3 of them here, and so you may have something like this. Okay, well, that's three assignment statements. You can see that there's redundancy going on because this is the same as this, except for this one variable here, and same with this. This is the same except for this one variable. And so what you can do is you can make a function like right over here, and this is exactly how it is. Let's call this function capital F, capital 2, capital F, capital A2, and then capital C. That would be Fahrenheit to Celsius, I guess, or centigrade, whichever you call it. What do they call it? Celsius. And so there's the parameter, by the way. On the function side, this is called a parameter. On the calling side, this is the main program, and this calls that same function 3 times, you see. And this thing that you put in here is called the argument. So on this side, this is called the argument. On this side, this is called the parameter. This is a parameter of the function. The function's got to be able to respond to this is the parameter of what the function's got to be able to respond to, and what it does. And so what happens is our code inside, and this is a very simple function. It's only 1 line. Functions can be lots and lots of lines. We take F, we take this parameter, and we subtract 32 from it. Then we multiply it by 5 and divide by 9, and we get this value here, which we are going to call C. and then we return C. Okay, so this, when we say return C, then that means that over in the main program where we called it, it's going to, when this is done being evaluated, there's going to be whatever the value of C is right there. And so C1 is set equal to C. C2 is equal to, whatever. So that's a function, and you can see the value of it. First of all, it reduces redundancy, and it also helps it so you don't make a mistake. Because here you're writing something 3 times, it's easy to make a mistake. So function definition, calling the function, defining the function. So that's what we just saw. We have to in Python. I haven't verified this, but I'm quite positive you have to define the function before you can use the function. A lot of languages are that way. Other languages, it doesn't matter where you define the function, it just has to be defined in the program someplace. But anyway, that's why you always see the definition of the function before it's ever used. So in this example here, we have a function. This is the definition of the function right here. And you don't need to, there's no parameter. It doesn't look like there's a parameter, so it just is a fixed value. Oh, if the fixed value is, this returns the area of the pizza based on the diameter. So you have a diameter of 12, and it computes the area, which is via this program here, and then returns this pizza value. So over here, this is where the function is called. So what's going to be replaced in there is going to be whatever this calculates out to, whatever that calculates out to. Okay, now, by the way, they never say this here, but this is also a function, but that's a system defined function. And look, it's not on the right side of an equal sign. It's all by itself, which means it's a function that doesn't return anything. It just does something. So so take a look at this. We're still in 6.1. Okay, these are new kinds of animations now. They're kind of interesting. This goes through the steps of calling a function here. Here we have a little program where first it writes out, say, cheese, and then it prints whatever this get face function returns, and we see that it returns this. It's just it's supposed to make a face. Looks like this is the eyes, and this is the nose, and this is the mouth. So you can execute this by executing this, and you see down here, there's a result of the function call, and then it says, did it turn out okay? So anyway, let's do a challenge. So we have this function called getPattern that returns 5 characters. It's 5 asterisks. Call it getPattern twice to print in the print statements to return and print 10 characters. Example output is this. So this is just too well. Okay, so I guess we're just supposed to get the idea here. This is a case of, I don't understand functions, but so I guess you can just do getPattern. We're printing something. So we have to do something with what the result is. So I'm going to say print getPattern. And then I'm going to do it again. Now I could do this. Now you see, we know that that's correct. But how about something like this? Oops, no, that's wrong language. Define a variable p equals getPattern. See, so we just execute the function once, and now we have this p, and we can print p here. Print p once, and then print p again. So, I don't know if this will work. Let's see if it does. Oh, yes, it works. Of course it works. All right. So, anyway, this other way of doing it where you have this in here. This is another thing that that I think the book like this should point out, but it doesn't. And that is, this idea of functions and parameters and arguments and so on. We just the the input function is a function. int parentheses, that's a function. And so right away right in the first chapter or whatever it is, we just throw out there int parentheses input parentheses, parentheses. So you're supposed to just see that, oh, these are functions, and there's two functions here, and one function happens to be an argument for the other function, and and then it returns. The first function that's executed is the input because it grabs it from the keyboard and that returns a value, and that again now serves as an argument to the int function, and that converts the characters of some bunch of digits, returns the value of whatever that represents, whatever that represents, and that returns something. So I think that, I don't know if anybody has a problem understanding this chapter. I imagine there's some people that do. That might be a way of seeing that. But I don't know. I think some of this stuff is pretty natural for some people, and those the kind of people, this kind of understanding this. If you're going through all these chapters and everything just makes total sense, yeah, of course, okay, that makes sense. Then programming is probably for you. If you go through this and it's more or less, you're learning and you're understanding why, or but it's not obvious. It's not something that you retain very very easily. And so maybe programming the job of coding every day would not be the first thing that you'd want to do that day. Now, the other thing, of course, is there's people that become programmers, and maybe programming is not their first choice, but they kind of want to get in. Well, they're programmers for a year, and then they move up, and pretty soon they're managing programmers, or they're defining what programmers should program, or they make the assignments of the programmers program, and then they check to make sure the programs are correct and so on. So anyway, just want to point that out to you. I remember I started out in computer science in 1970. Well, uh, in the early 70s, when I was in college, everybody who was in computer science really liked computers, and they were there because they were leaving math, or they were leaving electrical engineering or something. They were coming over to computer science, so they were programmers at heart. And then it wasn't until the early 90s when I started teaching computer science, and I taught the beginning programming class over at Manoa, ITS128, and back then we taught a language called Pascal, and that's the first time I had students that they didn't seem to really like programming, and they struggled to get the program to work and everything, and I thought it was kind of a dilemma. I thought, well, why are you here in computer science when really I can tell your heart isn't in it, or I mean, I didn't say that, but and then I realized, then I just thought about it a little bit, and yeah, there's a lot of people that start out in fields, and then that's a springboard. I remember when I was an electrical engineer, and I liked to design stuff. Okay, so that's why I became an electrical engineer, and I worked at Sperry Univac, and the reps from the the folks that we bought the chips from, Texas Instruments and National Semiconductor and Intel and they would come and they would, tell us about the new chips that are coming down the line. And I find out they're all the electrical engineers. They went to the same school I went to, and I'm well, why aren't you designing it? Oh, the school was easy for them, but they don't want to design stuff. They want to sell stuff. They want to learn about the new shit, and then they sell it, and they're the experts in it, and they get excited about that kind of stuff. And yeah, those guys are valuable because they understand exactly what you're going to do with it. They're there to support you. But anyway, so those of you that are starting out, some of you guys are starting out, and you aren't sure while you're here, just stick with it. In this course, just stick with it, and you'll do well. And then after this course is done is when you decide, you start thinking, well, do I really like programming? And there's lots of stuff you can do. Cybersecurity is another very strong field. You got to know how to program a little bit, but this course is fine. You learn about functions. That's as high as you go. You have to learn about loops, if then structures and all that, functions. And then after that, cybersecurity, it's all about the functions. And sometimes you'll write the functions, and lots of times you find some function, you adopt it, and you put that in something, and that keeps whatever you're supposed to do. I don't know, keeps the cyber criminals out. Anyway, let's get back to this. So here this calculate pizza volume has evolved to having two parameters in this function definition here. The diameter that you want the pizza to be, and the height. The diameter of the pizza that you're making, and the height of the pizza that you're making, and then it's going to compute the volume. Okay, so it takes diameter, radius. You got to figure out the radius from the diameter. It's half the diameter. You got to square it and multiply it by pi, this value pi, and that gets the area, and then you multiply that area by the height of the pizza, and that gives you the volume, and so that's the number you return. So when we use this function right here, we're printing out what the volume of a 12-inch diameter pizza, 0.3 inches high, and then this is same diameter, 8 inches high, or 0.8 inches high, and this is a 16 inch diameter with 0.8. So anyway, so here we've defined our function. That's how, and it's evolved, and this is how you should write code also. You start by just doing this up here where everything is, as they say, hard coded. Everything is hard coded. You get this to run, and then you start turning this into an argument, and turning the height there's no height here, but turning that into an argument. All right, so are there more? Okay, what's this one? Okay, basic function call. Complete the function definition to return hours given minutes. Okay, so basically given minutes, that means that's the parameter, that's the argument, and it should return what the number of hours is given what the number of minutes is. And of course, there are 60 minutes to an hour, so it should be take the minutes divided by 60, and that's how many hours is. And so this is the input, and this is the output. So so we have a function here that we're supposed to define, and this is how it's used. We read in we use the input function to get something from the keyboard, and this function here, I'm kind of being facetious and exaggerating, but this function here returns what a character string that the user typed into the keyboard, and that character string serves as the argument to this function, this float function. So it changes that string of characters into the value that can be used in an arithmetic expression, and so that is a value that can be used in an arithmetic expression, and that's a parameter. That's an argument to the function that we're going to define. So we take this thing that we can do calculations on, it's a number, so we can, multiply and divide, and that comes in as this. And so let's see what we do with that. We're going to compute hours. I'm going to call it hours. How's that? Equals original minutes divided by 60. And I'm going to do the floating point kind of 60 or divide, because it's a floating point number. And then I'm going to return that number, return hours. And so then whatever this ends up being, that's going to be returned in place of this, in place of this. And so that's what's going to print. What's going to print is the 3.5. Okay, so did I get all the points you said? Okay, so what's next? Okay, enter the output of the return value. So we have a function. Okay, so we're going to print the output of this function. What is this function? Well, it takes a parameter, it adds 1 to it, and that's what it returns. So this should return 3. So what should print is 3. And very good. 3 is printed. Let's see what number 3 is here. So here, change. Well, here it takes a 2 and a 3, a 2 and a 3, and it adds them together, and so that makes 5, and that's 5, and it returns 5. So this is replaced with 5. This is replaced with 5, and so it's printed as 5, I think. Oh, that's good. Okay, what's this one here? Define a function called that, which has 1 parameter and returns the parameter plus 6.6. Okay, well, of course. Okay, define a function called calcval. Okay, now you notice that I'm just going to replace this thing with that. Oh, hold on, I got to start it first. Okay, now I'm going to replace this with what I just copied. Okay, so calcval colon. You notice when you say define a function calcval, this is a function that has a parameter, but they don't put that here. Whenever they talk about a function by name, they don't put the number, they don't put any parameters in there. They just leave it with no parameters. But the fact that it's got beginning parentheses, end parentheses, that means it's a function. That it always indicates it's a function. So so even though I'm doing that, there's going to be 1 parameter. So I'm going to call that parameter, just because I want to. And it returns the parameter plus 6.6. So we're going to say return parameter plus 6.6. Is that all? Let's see, check. Oh, uh-oh. Wait, wait, what did I do wrong? Calcval. Wait a minute. Def. Okay, so earlier today I was writing PHP code, and I was defining functions, and that's the key word for that is function. But in this language, it's def. Of course, def. That's function, right? It means function. That means it means define. Define function. And so I got that one. What's the next one? Oh, it is define a function compute val that has two parameters and returns the result of subtracting the second one from the product of two. What? It returns the result of subtracting the second parameter from the product of two and the first parameter. The product of two and the first parameter. So what that means is the product, which is the result of, which is the multiplication result of two and the first parameter. This is the first parameter. So it's two times, that's because it's a product. So it's two times two. It's two times this, which is going to be 11. And then we subtract the first, no. Oh, then we subtract the second parameter from that. So 11 minus 6.5 is 4.5. That's why that is. Okay, so what it is def compute val, two parameters, P1, P2. And we're going to return P1 times 2 minus P2. Okay, that's what I think. Yes, okay, hope that made sense to you. All right, what's next? Print functions. Okay, so this is a popular thing to do where you when you want to print out some stuff in your program, you just make a function to do it, and that takes care of all these print commands. And because sometimes just to print one thing, you got to have like 3 or 4 or 5 or 10 print statements and all this print formatting and everything. And so you kind of put all that in one function, and it kind of makes things easier, and you aren't cluttering up your main program with a bunch of these irritating print statements that take up a lot of space and everything. So so that's what this talks about. It's a good practice. Printing out a menu, and then you just say that, and it prints out the menu, you take a choice, and so on. So let's just do some of these challenges. Let's do this first one here. I'm going to define a function called print age, and then it says it's like F apostrophe IM. It's like if I put my age in there, I'd say I'm and just making a joke. Okay, so age to print is 24, and then this is the function. It's the function 24. So I would print I am 24. And since it's a print, I go like this. Is that all this is? All right, let's go to the last one. You can do the ones in between. Print points. So it's going to print out the person's name. It's going to print out the age of the person. It's going to print out the total points of the person, whatever these are. So this is where it takes care of the name and the age printing. And this is where they take care of, they can say the name again, and then they print out they output the total points. So this is what happens to these 3 parameters. Name gets used twice and the other 2 get used once. And here we just load them up. And we pass in, these are the arguments. This is Bob. This is 19. This is 23 plus 7, which is 30. So this computes to 30. And these 3 values are the three arguments that get passed to this, and this is the first argument comes in as this name parameter, age, and total points, which is this 23 plus 7. So what gets printed? Bob is 19, and Bob made 30 points. Enter. Let's see if this is right. Ah, very good. Excellent. Okay. What's next? Print functions. Okay, we're gonna have to write some print functions because I can never remember these detail of these formats, but that's the value. That's being able to scroll will help me there. Two location population pairs, that'd be like a place and a number, are read from input and are passed as arguments to this def. Def a function called this that has two parameters and outputs the following all on one line. Okay, so we're going to print first parameter has second parameter people. So first parameter has second parameter people. So let's make this print city details. So I'm going to copy this. I'm going to put that here. And I'm going to go back. I'll put a colon there so I don't forget. And I'm going to put whatever, P1, P2, whatever. Okay, and it's supposed to print value of the first parameter is print all in one line. Print, okay, what do I do now? I do this F thing. No, I just copy this here because I can never remember this. Such detail in this language. Help you write. Oh, I wonder what that is. I'll have to check that out. Okay, so I'm going to say this is the value of the first parameter, that's P1. P1 has P2 people. Okay. See if it works. Did I forget a period or anything? Ah, did I forget a period? Yes, I forgot a period. Let's see me get dinged in the period. Oh. Oh, wait. What did I not do? Oh, I forgot to put the word def. Forgot the word def. That was easy. Uh-oh. Forgot the period. Okay, well, you can fix the period. Let's go on to the next one. Can I do that? Yeah, let's go on to the last one. Okay. Read the four values from input and call that twice. Oh, okay. Read four values. Okay, here we go. Now, do I have to worry about int and so on? Well, doesn't matter. It'll tell me if I'm wrong. So I'm supposed to read in four things. I'm going to read in four values. V1 equals input. V2 equals input. V3 equals input. And V4 equals input. Okay, and then I'm supposed to I'm supposed to print, print city details using the first and the third inputs as arguments. That would be V1 comma V3. And then call it again, city details. Oops, should have a V2 comma V4. Okay. Okay, I'm gonna see if this works. Okay, I got that one. All right. Okay, so what's dynamic typing? Okay, dynamic typing is important. This is a thing that's kind of unique to this language. It's that okay, so in here in this function, we're going to return x plus y. Now, x plus y, what does that mean? Well, if x and y are numbers, like, digits, integers or floating point numbers, x plus y means add the two together. If x and y are character strings, then the plus sign indicates concatenation. And you are concatenating the x, you're concatenating the y onto the end of the x. So you see this is going to print out, 12, and this is going to print out Tora Bora. So if we go through this and see that, well, that's the end. Okay, anyway, see, so 12 and Tora Bora. Okay, so and so that's what dynamic typing is. The typing of these two in this definition of this function, the type of these two parameters is defined by the operation that is done on it. So no. Is defined by what they are when they come in, not by the operation that's done on it. So if these come in as character strings, then they can be character strings. The type is a string, and then when we do the plus function, the plus operation, it ends up concatenating them and so on. So you know what I mean. Okay, so and adding polymorphism. For example, consider the multiplication operator. If two operands are numbers, then the result is the product of the two numbers. In other words, they're the result that you get when you multiply them. If one of the operations is a string and the other one is a number, then we are repeating this character string this many times. So this is going to be this. Okay, that's something in Python. So that's what this dynamic typing is. It just points out that other languages like C, C++, and Java use static typing, where first of all you have to define all your variables up at the top, and then when you define you define them by name, and then when you do that, you have to say what type they are. You have to say if it's an integer. You have to say if it's a floating point number, a double. You have to say if it's a string, and so on. And then after that, that's what they are. You can't change them. Well, you can do things like casting and so on, but you can do that in Python too. All right, so here we talk about the reasons for defining functions. They're all the reasons I talked to you about already, and they're all the reasons that you would think that makes sense. Readability, modular program development. When you're writing code, top down. The term we used back in when I started programming, term we used to use back in the 90s is called top-down structured programming, where you write the code for using the function before you write the code for the function. And so what you would do is you would write code that uses the function, and then you'd go down and you'd have your def statement to define the function, but then you would just put a stub, what's called a stub there, or you just say, return, or you just have it return some bogus value, or you just put something there so when the program runs, you don't get an error. And so it can be it, but and then you debug the code that's gonna use the function. You do that before you actually debug the function, and that's good because it makes the function really well defined. You know exactly what the function should do before you actually start coding the function. Okay, so avoiding redundant code. Without the first example was that when we were computing the converting temperature, that's redundant code. Here's another example. What other reasons are there? I don't know. Okay, so what's this? Factoring out a unit conversion calculation. Write a function so that the main program below can be replaced with simpler code that calls function this. So we're going to read this in, and we're going to read this in, and then we're going to compute this based on these two arguments of the first one and the second one. And this is the first one. Oh, it takes these two numbers, and this is the calculation that it does. Where do we print there? Okay, so it looks like this is the calculation. Something like this. All right, I'm gonna say take this, copy. I'm gonna put that right up here. Def that. And then I'm gonna put this there. Paste. Paste. Oops. So that's the and we're supposed to return miles traveled, aren't we? So we're supposed to return miles traveled. So I don't know if this is right. Let's see if it is. Oh, great. Oops. Right. Oh, no, not all pass. What is it? Oh, there it is. Okay, very good. Okay, so, writing mathematical functions. A function is defined as a mathematical function involving several numerical parameters, returning a numerical result. Well, that makes sense. That's pretty obvious. The parameters are numbers, and it returns a number. So we do a lot of that. Temperature conversion. This looks familiar. Compute the square. You take this number and you multiply it by itself and you return that. Mathematical function, that's great. All right, let's do this one. Assign max sum to the greater of this one and this one. Okay, so it looks like there's going to be 4 parameters. Oh, wait, what am I supposed to do? Okay, so I'm supposed to where's max sum? Okay, so what I'm supposed to do is compute max sum. Is this a challenge? Okay. Oh, I'm supposed to write this out. Okay, got it. Okay, max sum. Um, so I'm going to say, okay, so what this is I put in 2 numbers and I get a maximum. It's the greater of these 2 numbers. So I put in these 2 numbers and I take the maximum of those 2 numbers. And then I add to that the greater of these 2 numbers. So basically I find the greater of these 2 numbers and I find the greater of these 2 numbers and I add those 2 together. And that's what max sum is. Okay, call find max twice okay, so I'm going to say my thing is going to be here max sum. I'm just going to, okay, first I gotta, oh, it gives me that. Okay, so I'm going to say oh, max sum is okay. Max sum equals what's it called? Find max. Find max of num A and num B. And I want to add to that the find max of num Y and num Z. So 10 plus 7 is 17. Okay, good. So is this right? Yeah, all right. Okay, so this is more examples. What is this? Okay, complete the gallons to liters. It has one parameter as volume in gallons and returns the liters. And 1 gallon equals that many liters. So gallons to liter, this is the factor. So gallons, okay, so it's going to be do I have to say that I'm using this? Oh, wait, I don't think I do. Okay, so let's return. I have to press start first. Return I get user gallons times gallons to liters. Okay, now I don't know if I need to tell it Oh, did I? Oh, modular function. Okay, so um, there are a whole bunch of methods that are built in that this is the first time we mention it. Okay, so and so these are um, have we talked about importing the math functions yet? We have. Okay, all right. So, okay, so that's what this is. Yeah. So this is a sort of a well, it's a constant. It's kind of like a function without any parameters, but um, I don't see. Oh, the only thing I see is this thing. Okay. So anyway, so let's see if this works. And what I'm wondering about is in some these just mixed up. Okay, that seems to work. All right, let's see what the last one is, and we can maybe I won't do it, but I'll just. All right, so we're supposed to. The function is this and this. You're supposed to write two. We're supposed to write this function. Um, and then this function. Base area is a thing. So we read the user side length, and then we compute the area. Hmm. Oh, this computes the air. Oh, I see. We're supposed to write these functions. Okay. So you do something like def this one, and that's going to be something like campaign call is well, you can return. You can let's see if we can do it all in one line. Return the parameter is user side length, right? And I'll just do see user side length. Okay, user side length. Return the user side length squared, right? That's what I return. Okay, user side length times user side length. I hope you get that. User side length. Okay, so that's going to return the user side length squared, and that's what that's going to be. And then this is going to compute the surface area. So compute, and I suppose it wants me to use this function. So I'm going to go def this. Should have just done this before. Oh, look at that. I should have just done this. Is user side length is first of all the base area. First of all, I have to compute the base area, which is a user. Well, I'm going to go back to user side length, just because I want to, because I don't have to type so much. It's first I got to compute the base area. I'm going to use this function. So I'm going to say return compute base area. No. Oh yeah, that of US1, USL, user base area times 6. Okay. So this, when it comes time to returning this, that surface area, oops, is equal to the base area times 6. So surface area is equal to the base area times 6. And base area is computed with this formula, which is the side length times side length squared. So that's why when this is called, it's this and it's this squared. I think this is right. Let's see. Uh-oh. Return. Oh, that's right. What was I thinking? There we go. Very good. Okay. What's next? Function stubs. Okay, so I mentioned this earlier already. Function stubs, where you can just put something in there so your program will run. Incremental development. We used to call it stepwise refinement. You do function stubs, top-down structured programming. It's so here we're gonna we're writing our program here, and okay, so we have this thing where we want to enter the number of steps, then we want to compute the number of feet, print that out, and we want to compute the number of calories based on the number of steps or whatever. Steps. Yeah. And then so we look at defining steps to feet. We did that, but then defining steps to calories, we haven't done that yet. So we just say pass. So that way it's not going to print anything out. This is going to be like none. Return the word none. See, that's something that Python does. No other languages do this. So because this is not going to not returning anything, it returns this keyword, which is none. That means there is none. All right, so that's a stub, and this is another kind of stub. Just put a print statement saying fix me, whatever. And you can raise if you catch what's the okay, that's what happens. But why would you want to raise that on purpose? I'm not sure. It could be so you maintain control of your program. But anyway, so define stubs for these functions. Each stub should say fix me and then name of the function, followed by a new line, followed by a -1. Each stub must also contain the function's parameters. Okay, so it's I'll just do this last one. So we're supposed to do two of them. Functions def get user num, and it's going to have a parameter which is parameter. Each stub must also contain the function's parameters. Oh, this is a function that has parameters. This is not. Okay, so so here we're gonna have this get user num, and so that has no parameters, and that's supposed to print out print. Let's get fingers in the right place. Print that, and then return -1. And So this is what we want to print out for the first one. Copy. Here we go. Paste, print that. And for the next one, we want to do def compute this thing. And we want to nothing, just do the same thing. Print, do these things. But instead you want to do this. Okay, I wonder if this is going to work. Yes. Okay. All right. Well, let's see. Did we actually get, this is chapter 6, the 6.9. Did we get to 6.9? Oh, no, we didn't get to 6. Oh, okay. Well, that's fine. So branches and loops, all this is functions can be full-blown programs with branches and loops in it. That's all this is doing. And then this this thing, see, this has some branches and some loops. So that makes sense. Of course, functions can have branches and loops. They're just programs. This next thing is functions are objects. This has to do with, in Python, you can name, you have a list, and then if you set some other name equal to the list, it's still the list. It's just another name for the same list. So if you assign a new name to a list, then you can manipulate the list using the new name or the old name. There's that naming thing in Python, which you don't really see in other languages. That applies to functions also. So that's all this is. You can have a function, and then here you have a function called print face, and here you execute it, and then you say that this is equal to that. Okay, well this is a function. Okay, well that means that this is also a function, and so you can call this function by just like that, and it's actually the same function. See, that's what this is this was showing over here. So that's what they talk about when they're talking about functions as objects. That's what they're talking about. And I don't know why you even ever need to know that. I suppose you could come up with some reason that makes it handy or more understandable if you rename things like that. But anyway, maybe I'm just expressing my naivety. But so that takes care of up to 6.9. What's 6.9? Oh, common errors in functions. So yeah, I should probably go over this, but it's just what you'd think. Common errors in copying one function to another. You get something wrong. You get a plus sign instead of a minus sign or whatever. Anyway, so that's stop sharing. Stop. Okay, so that's all I have for today. Any questions? Okay, so can you send me an email and I'll send it to Tay, and then we will make sure you get credit, although you would not credit. So it is. Make sure you attended the face-to-face class. Huh? Well, just send it to him. Oh, yeah. And then I'll mention it. All right, so that's all I have for today. Any questions, just email me, and I will see you next week. Thanks for watching.